Hi, welcome to another video for chemistry. In this video, we're going to expand on atmospheric pressure or gas pressure. We're going to talk about how we derive the units that we're going to use in the problems. You're going to hear of a law called ideal gas law, where we use pressure, and it's the standard pressure is 1 atmosphere. So we'll discuss how we derive that. So here we have our planet Earth, and you'll see again the column of air that we used in the previous video. This column of air again represents the different layers of atmosphere on Earth. So Earth's gravitational pull maintains an atmosphere. It keeps all the molecules in a certain place on Earth for us to enjoy and to breathe in and such. So as you get down lower, closer to the surface of the Earth, because of the increased influence of Earth's gravity, you're going to have an increase of density, an increase of molecules as you get closer to the Earth. So you're going to have more oxygen molecules to breathe, for example, at the surface of the Earth than you are at a height of Mount Everest. So on a molecular level, air pressure results from collisions between the air molecules and any surface with which they come in contact. Just think for a moment if you're at the bottom of the ocean, right? Well, actually no, let's go back to the surface of the Earth. At the surface of the Earth, your internal pressure, you have a pressure that's pushing everything out. But at the same time, you have an external pressure that's pushing everything in that balances itself out, and it keeps you intact. Well, if you were to go to the bottom of the ocean, right? So as you're going down lower and lower and lower, and you're increasing the density of water molecules, you're increasing the pressure and weight on you, your internal pressure is still working, but it's going to be overcome by the external pressure of all the weight of water on top of you, and it's going to basically collapse you. It's going to crush you. Okay, so that external pressure will be much greater than the internal pressure that your body has. Well, luckily that doesn't happen on the surface of the Earth, but we do have, the point still stands, where you do have an increase of pressure, an increase of air molecules that are colliding with your body that balance out the pressure from the inside of your body. So the magnitude of pressure depends on how often and how strongly the molecules impact the surface. So this idea plays an important part in measuring and how we measure pressure in the atmosphere. Okay, so here we have a barometer, a mercury barometer. This is a little ingenious device that was made by Evangelista Torricelli. Okay, he designed this mechanism to actually measure the pressure in the atmosphere. So let me describe how he did this. So he filled up a tube with mercury, and he very carefully, so that no air would get trapped inside, poured this tube into another container, and some of that mercury poured out into the bottom, and it left a little vacuum at the top. So there's two things to consider with this mechanism. The vacuum at the top, you'll notice that the mercury did not continue to pour out, and it just maintained that column. So that mercury that filled up the tube is actually laying at the bottom, but it didn't continue to pour out. Something kept it from pouring completely out, and that's the pressure, the atmospheric pressure that was pushing back on it. So atmospheric pressure maintained that column of mercury that you see, and the measure of that column is 76 centimeters, or 760 millimeters. And this is where we derive the units for atmospheric pressure. Okay, and that equals to 1 atmosphere, 1 atm. So it is equal to the pressure that supports the column of mercury. Now, something to consider. And these units you need to have memorized, okay? So 76 centimeters of mercury equals 760 millimeters of mercury. And remember what that number stands for, okay? That stands for the length or the height of the column of mercury on our barometer, which also equals 1 atmosphere, and also equals 1.01325 times 10 to the 5th pascals, or 1.01325 to the second kilopascals. And yes, you need to memorize these units. These units are all equal to each other. And you're going to see in word problems later on in a future video that you need to have these memorized, because you have a problem that might give you a certain unit, but it might be asking you to give a final answer in another unit. So you'll need to know the conversions. These are all conversion factors that you need to memorize. Okay, so let's highlight the 760 millimeters mercury real quick. There's also another unit that you need to have memorized, another conversion unit if there wasn't enough already for pressure, and that's 760 torr. Luckily this one's a little easier because it's a direct 1-to-1 ratio. For every 1 millimeter mercury you have 1 torr. So where did that torr unit come from? Well, they came from Evangelista Torricelli, the actual inventor of the mechanism for measuring pressure, atmospheric pressure. Okay, so that does it. Again, this video was just to highlight how we attained the unit of atmospheric pressure, and that's thanks to Evangelista Torricelli. So I hope this video helped, and like I mentioned before, there'll be other videos where we actually use these units in word problems. All right, good luck in your study.